Electromagnetism is called temporary magnetism since it only exists while a current is passing. An electromagnet can be switched on and off unlike a permanent magnet. Electromagnets are used in scrap yards as a convenient way of moving ferrous metals, iron and steel, and separating them from non-ferrous metals such as aluminum, copper and brass. When a current passes through a wire, a magnetic field is generated around it. However, to make a practical electromagnet, the wire is wound into a coil. An electromagnet's strength can be found by measuring the weight of iron, which it can support. A simple comparison of the strengths of electromagnets can be made using small articles, e.g. nails or paper clips. Horseshoe electromagnet. A horseshoe electromagnet can be made by winding a coil around each limb of a soft iron core. If the coils are wound around the limbs in the same direction, the magnetic fields cancel each other out, and the core is not magnetized. If the coils are wound around the limbs in opposite directions, the limbs are magnetized with opposite polarity. 1 electric doorbell. When the switch is closed, the circuit is complete and current flows through the coil. The soft iron core becomes magnetic and attracts the armature. As the armature moves, it strikes the gong, while at the same time breaking the circuit. The soft iron core ceases to be magnetic and the steel spring returns the armature to its original position, completing the circuit once again. The cycle is repeated for as long as the switch remains closed, causing the bell to ring. Doorbell with chimes. When the switch is closed, the coil of insulated copper wire becomes an electromagnet and the soft iron collar is pulled down into it, causing the polyethylene bobbin to strike the lower metal plate. The spring is compressed and forces the polyethylene bobbin and soft iron collar back up again to strike the upper metal plate. The bobbin will continue to oscillate up and down in this way while the switch is closed. 3 telephone earpiece. A variable current passes through the coil in the earpiece. This produces changes in the strength of the magnetic field below the diaphragm, which causes it to move up and down, making sound waves. 4 magnetic relay. When the switch is closed, current flows through the coil and the soft iron core becomes magnetic. As one end of the armature is attracted downward towards the core, the other end moves upwards, closing the contacts.